Okay, so this week we're gonna touch a little bit on IP address and binary. Next week, we're gonna go over a little bit of another number system so you can understand how the MAC address is made up another number system. And then the following week, then we're gonna actually look at subnet. But I want to gradually bring you into subnetting. I know it's a challenging topic for most. So today we're going to touch on the components of IP address. And then looking at what the computer sees as IP address, right? And how it's able to route your packets to the location. And then when you do the lab, you're going to actually look at the packets that were routed. So you can be able to understand how to use the protocol analyzer. Okay. So we're gonna look at the chapter 3, week 4 notes, and then we are going to work on our assignments together. So as we learned in the past, right, in the last week or so, we talked about OSI layers, and IP is at layer 3. This is when the router is able to bring traffic into your network and leaving your network. And IP address is very important in IT and cybersecurity, not just for system communication. But as you can see, if you are looking for as cybersecurity specialists or analysts, a lot of the time we are looking at target IP address or IP address that could be in range, that's on our segment that could be attacked or impacted. So we wanted to know what it is, right? What is it made of? And how we use it. So an IP address, and today we're going to talk mostly about IP version 4. So IP version 4 has been supposedly announced to be ran out in 2011, public IP that is, right? But you have cloud companies and tech companies that still have a lot of the IPv4 that they are currently using for their server. Even though it's been more than 15 years, we are gradually transitioning into IPv6. And down the line in the future, right, you will see the IPv6 will also run out, and then we will have to come up with a different system. But today, because you are at the cusp of a lot of the systems still using IPv4, along with IPv6, we have to know how to use it. So IP version 4 is made up of 32-bit value. Okay, so when you're looking at an IP address like this one, 192.168.1.15, this is something that you might see on your home network, right? The 192 is a Class C address. It's really designed for a smaller network with fewer systems compared to the other classes. And we'll touch on the class near the end of the lecture. So each of the octet here, the 192, the 168, and the 115, they are separated by the dot or the period, okay? So we would say 192 dot, right? That's an octet, which is made of 8 bits, okay? The next octet is also made of 8 bits. So if you combine 4 pieces together, each is 8 bits, you get 32 bits. So the IP version 4 is made up of 32-bit addresses. Now, when you look at the address, usually we would be able to identify what is a host ID, right? And what is a network ID. And the network ID is mostly be used by your router or your network appliance to be able to navigate the packets to the right area of the network. So the router's job is to bring the traffic to the area, the network section, right? The network itself, okay? The switch is going to then take it down to the specific system. So in the IP address, it's made up of 2 pieces, which is the component is going to be a network ID and a host ID. And we'll come back to this shortly. Okay, so when we go through the assignment, let's answer the first question together. Number one, how many bits are in IPv4 address? We said that it is IP version 4 is made up of 32 bits. The number that you see is a decimal number, okay? The decimal number is our human counting number. What you learn when you start learning how to count, like 1, 2, 3, 4, 5. You also learn arithmetic in elementary school with decimal values. So in decimal numbers, it is a base 10 number, 0 through 9. You have 10 increments. And then we repeat again, right? So it is a base 10 number. The computer sees everything in binary, 0 and 1s. It is a base 2 number. So for a 32-bit address that's version 4, it is presented in decimal value. The 192.168.1.15 we looked at earlier, that's a decimal value. The computer has to take that and convert it into a binary value so that way it can see, right, which system is requesting or receiving. Okay. Now, we said that each of the octet, there are 4 octets, and each of them are separated by the dot. That's going to be made up of 8 bits. So there are 4 octets, 4 pieces, right? And each of the piece is going to be 8 bits. So if you take 4 times 8, you have 32. All right. So before we go to the next one, let's go through and talk about host ID and network ID. So network ID is very much like being in the same town with another person. For example, I live in Moreno Valley, right? Some of you might live in Moreno Valley. So we recognize ourselves as residents of Moreno Valley. The system's in the same way. The network ID is then sometimes shared with the systems on the same segment, that particular network. The host ID is going to be unique to specific system. You cannot have the same host ID for multiple systems. So if I have 192.168.1.15, the host ID here is going to be the 15 value right here. Okay? And because this is a class C, we'll talk about the class later. So the host ID is going to be unique. Now, the next system will be 192.168.1.16, right? And then 17 and so on until we reach the maximum in that range. And by default, you can get up to 254 for the class C base address like that. Okay, we'll come back to this. Now, every IP address is going to be working with a subnet mask. So a subnet mask is like a zip code, okay? Or some would say like an area code, but area code doesn't work for telephone anymore that way, but like a zip code. So you can live in Riverside, right? And you can have 92501, or Moreno Valley, like the school here, it will be 92551. So this subnet mask really represents the area of the network that it needs to reach. Okay. Now, you would always see that subnet mask is represented by the 255 value and the 0. 255 means that all the bits are on, and we will see this when we do the conversion. So the system simply looked at the signal, right? Computer is an integrated circuit system. So it's simply looking at electrical signal, and it's going to say, if all the bits are on, right? If the signal is high for all the bits here, here, and here, that it knows that that is the part of the network that needs to reach. Okay, it's simply looking at the signal, and then the 0 is when it's off. So it would reach a certain volt, and then for all the bits to get the 1s, for the 8 bits for each of the octet, and then when it gets here, right, to the host ID, it would be 0. So you would see that the subnet masks really get it to the area of the network, just like how when you're shipping a package, it just needs to get to the post office of your zip code, right? But then to get it delivered to your house, it needs to take a look at your host ID, the last value to know the individual home address. So each of the system, this value right here is going to be unique. It cannot be the same, okay? So if you have a conflict in IP address, you're gonna have network miscommunication and an error will be notified, right? It will tell you. Okay, any question? Okay, so when we look at this address, right, this is a Class C default address. And when you look at the part of the notes that's later, it talks about the classes. So when we look at the 255, 255, 255.0 for the subnet mask, remember what I said, that's the zip code. It always worked with the IP. We would say that this is network ID, network ID, network ID, and the host is 0. So when when the router looks at the subnet mask, it just knows that this is the network that it needs to get to. And then from that point on, the switch is going to look at the table and it's going to say, oh, it needs to send it to this MAC address that has the associated IP address, okay, which is the number 15. So you're going to have network ID, network ID, network ID. So whenever you see a default class address, the 255 represent the network ID, okay? Now, when will it get to 256? Never, because when you have one more bit, that will be overflowing the 8 bits, because if all the 8 bits are on, it will be at 255 in decimal value. Okay. We'll see why when we do the conversion. Okay, now, so for the next question, let's look through the IP address and do some practice. You have to know how to do this, because before you do the subnet, you have to, number 1, know the class of your address. Number 2, know which part of your address is a network ID or a host ID. So if we're looking at the first IP address, A, 192.168.0.100, right? And you're given a subnet mask 255, 255, 255.0. This is a default class C address. So like I said, whenever you see a default class address, you are going to identify the parts that's going to be 255. So the first octet, the second octet, and the third octet, the first 3 octets are network ID. So it will be network, network, network host. Okay. So the router simply looks at the 3 octets to determine that's the network, right? Like a zip code. It would know which town based on your zip code. The second IP address is a .10, a 10 dot, okay? This is a common IP address that you see in a larger network. So if you use the 192.168.0.x, like the home network, you actually have less host system, right? You have less host systems, and it's used for smaller networks. That's why it's used for home or small business. If you're using a Class A address, and we'll take a look at the exponent and why it's more. Administrator, they like to use the 10, right? Can you use 11 or 12? You can, but by practice, we're just trained to use 10. So when you're looking at the address here, 10.0.0.1, and you're given a subnet mask 255.0.0.0 here, remember what I said? If it is a default class address, you see it like this, the 255 is going to indicate the network ID. So the first part of your IP, the first part of your subnet mask, that represents the network. That's a Class A. Okay. And then the rest is going to be used for host. So if I want to have multiple networks, here's 10.0.0.1, which is often used for a router. The next network will be 11, right? Because that's a different number than 10 or 9, right? Or the it could be 12 or it could be 14, right? So if this number is different than 10, the system is going to then treat it as a different network, you see? And if the last value is different than 1, it's going to treat it as a different system on that same network, okay? Understand? Okay.
Subnet was the beast for beast.
Yeah.
But it's getting better.
Okay. So the whole point in this exercise is to distinguish what part of the IP address is a network ID. That's very important. To begin network subnetting and networking, you have to understand what part of the IP address is the network ID. First, ask yourself, what class is the IP address? But because you're given a subnet mask here already, you would look at the subnet mask. This is a default subnet mask for class A. So the 255 represent the network ID and the 10 is the network ID. Okay, the rest is for the host. Next, C, 172.1.1.1. This is the given IP address. And here's your subnet mask, 255.255.0.0. This is a default class B address. And as you can see, the 255 represents the network ID. So that means that these 2 octet in the front are going to be network ID. Okay. So you look at the subnet mask, which octet is the network ID, and that should reflect on your IP address, which octet is the network ID. Okay. Any questions? Yes, I see a hand here and then come back. Say it again.
What's the letters?
Yeah, so network, host, host, host. So network ID, host ID, host ID, host ID. Okay, so that means that this octet, the first octet is the network ID, right? And then the subsequent are the host ID. So C, this is a class B, right? So network, and you had your hand up here, I forgot. Yeah.
So for like a VLAN, would it be the same network ID, but just a different host number or host ID?
No, because if you want to route to that VLAN or separate that VLAN, the network ID has to be different. So let's say that if I'm using V as one network, right? That's my router .1, right? And if I set up a VLAN on that same layer 4 switch, right? So let's say that that switch is already using a .1, this IP address. So what you want is on your VLAN setup, it's gonna be 11 in the front.
Okay.
Yeah. So it's gonna start. So let's say that you take half of the ports on that switch to set up your VLAN port, let's say 12 to 24. You're gonna configure those port and treat those port as a separate network. Then you have to use a different network IDs. So that means that that switch has to route to itself. You understand? So it has to leave the 10 network and come to the 11 network, even though it's physically on the same switch. That's how we're able to use virtual LAN. We set up another logical layer of the network that there's 2 networks, but only on one appliance, right? So virtualization is used that way, so that way we can save money instead of buying another router and be able to set it up. Yeah. Yeah. So good question, right? So if I wanted to treat it as a different network, I just change the network ID. You can go 9, you can go 11, you can go 14, as long as it is, right, a different network ID than that. Now, each of your port has to have different host ID as well, right? Because they're for individual system. Yeah, so if you plug in like copier, printer to those ports, they are individual identified with the host ID. But the 12 ports that you set up as VLANs, they all have like 11.0.0.x. You know, okay.
Thank you.
So 172 here, this is a class B. The first 2 octet are your network ID. So we indicate network, network, host, host. network, host. So the first two octet for your IP address is gonna be your network ID. That's how it's able to find this network, is using the first two octet. And then subsequently, and this one is a tricky one, we'll come back to this one also when we talk about subnetting. But you see this here, when you type in ipconfig and you find the IP address, they use a 10. So you see a 10.10.1.106, right? But the given subnet mask is 255.254.0.0. Sometimes when we use subnetting technique, what we do is we are using a class A address. When you look at the address, the octet right here, and the first part right here indicated that it could be class A, but what you do is you borrow into class B bits. So you're leaning into the next octet to have more IP addresses or to use it, for different subnet purposes. So in subnetting, the way that it's traditionally used is to be able to extend your network without changing a lot of configuration. You don't want to go in and modify the entire network, but to implement subnets so that way you can expand your network. Let's say that I first designed my network and I have used a class A address, but now I grew tremendously, right? You see this with social media company or companies that make it big. They now need to have more data center. They need to have more racks. They need to have more system, more employees, etc. So what we can do is we can implement subnetting by borrowing to the next octet to be able to have different networks, right? So what you see is you can have more networks by having additional bits here. So in this case, this is actually a bar. It's not a default class A or B, right? It is a subnet class B. So what you see is you see 10.10, right? We would treat it as a class B address. So the first two octet is going to be your network ID, and the same thing with IP address. So that means that when you look at an IP address, you need to take a look at your subnet mask, right? The 255 indicate the network ID, and you have to ask yourself, what class is it? Does it match the subnet mask? And if the subnet mask is changed like this, and where it's not 255, it's borrowing a bit, then what you see is you see the first two octet as the first two octet here are network ID. Okay, so this one is a tricky one. You see how to derive this in a few weeks. Right, I wanted to just ease you in to kind of show you what it looks like when you're looking at IP address, okay, when you're looking at your packets today. Any question? Okay. No question? Yes. Yeah, you can do that. You can borrow A to C, you can borrow. So I can have this address, but then using C subnet mask, it will be 255, 255, 252, or 254. And you see why when we do it. So what we do is we can lean, basically it's like this is your house, but you want to borrow into your neighbor's land to build additional storage or whatever, right? So there's a way that we can lean, and each of these octets, think of that as bits that we can utilize so that way the system can understand, like, oh, that's a separate network compared to the default network, for example. And you can do that when you have a bunch of VLANs. You can do that when you have, you expand it to different region, different part of the world, and so on. Okay. All right. So let's really try to understand how the computer send things back and forth. For 3, it says if the computer A is sending data to computer B, how does computer A locate computer B in the network? Right? So if I'm looking at one system and it needs to reach another system in the network, it would determine that based on the subnet mask. It would say, hey, is that computer in the same town that I live in? Right? Or is it in the same network, or is it in a different network, right? So the subnet masks tell us which network that is. And so if it is in the same network, right? Then, and it uses the network ID to compare that. So the network subnet mask is gonna help us narrow down the IP address network ID. Then from there, it's gonna say, oh, it's in the same network. So it just passes into the other system in the same network. Now, if it is not in the same network, then it has to, the traffic has to leave through the router, your gateway, okay? And reach wherever the destination would be. Question? Okay, so I hope this kind of gives you the very basics so you can understand like why things are set up a certain way for IP address. Okay, so when we're looking at this, right? If just that scenario that we talked about, 192.168, right? So network, right? Network host. So if you're looking at a 1 here and a 10 here, it sees it as different networks, right? But if you, and of course they are two separate systems, so this value is always going to be different. But technically, when you're looking at network ID, network ID, so if you change up the 1 to the 10, you make it into a different network, okay? And we would do this sequentially so we can maximize the number of systems per network. We don't just like jump from 1 through 10. We will go 1, 2, 3, 4, 5 until, you know, so you have multiple networks in between before you get to the 10. So logically, you kind of have to think about that when you design. Okay. And then for the default gateway, so when you set up your static IP address today, you have to think about the default gateway. And I mentioned this when you did the topology, right? Are you using your server as your gateway? So your gateway is treated as a system that would bring, right, that will format everything from outside to inside, right? It's like how somebody comes from outside of the country and they come to United States, right? And once they pass through the border, we would then have them converted into what we see as part of the country. So the system used the gateway to format everything to the network environment so that way you can have the same information on the same networks. So it tells you here, if two systems are different networks, and the system must pass the data through the router, right? And the router, we treat it as a default gateway, right? So the router, the host ID is always going to be 1 because if that's the first system that you see coming into a network, right? So if I'm coming from the internet, the router is the system that's going to bring me into the network. So a .1. Right? If I have a firewall behind the router, that's a .2 for the host ID, and then .3 maybe for a switch, right? .4 for a server, 5, and so on and so on. So you would logically design that with your IP address coming in from your default gateway. Okay. Any question regarding? Let me bring this back up because I think I moved this down for the Friday class. Okay, so to send data in the same network, what configuration is needed in the sending and the receiving system? So that means that even if you send it in the same network, right, because it uses the IP, the subnet mask to really determine whether that system is on the network or not. We are functioning with TCP/IP in general. And then the switch would determine which system that is by the MAC address. So you need a system IP address and a subnet mask. So as you install your computer Windows OS, you would notice even if you haven't connected to a network, it has a default APIPA network, and we'll talk about that, right? Microsoft has created or programmed an IP address for a system that is not really usable or routable, but the system must have an IP address to start. Okay. And then when you restart your system and connect it to your wireless router, it actually acquires the network IP address from the router, which functions as DHCP, a system that gives out IP address to the system on the network. Now, if you want the system to connect to the internet, it needs to have an IP address, a subnet mask, and a default gateway. So you need to put in your router IP address here, right? And you will see why when you do the Linux part of the lab, you're gonna be like, oh, I purposely have you type in a command to input that, right? But Linux Kali is not going to record that, and I edited and I added a little note, so you actually have to change the configuration, making sure that it is routable so that way that system can have internet connection. So if you don't put in a default gateway IP address, your router address, your system cannot leave, right? The traffic cannot leave your system to go to the internet, period. It doesn't know how, where, right? If let's say that you tell someone to leave your house and you don't show them the door or the gate, right? They don't know how to leave your house, right? So you have to be able to set that up. Okay, question? All right. So now let's let's get into the binary math a little bit. And it's really easy, not hard, right? Some of you have done this before and it will be reviewed for you. Some of you, this might be new, right? And if you need help or have questions, you can talk to me after class or see me during office hours. We can sit down. I teach the same thing to computer science students, but they need to understand the logic so that way they can program at low level, or when they use things like sign for the variable and they know what that means, right? And I make them do 2 complement. So the secret is the computer was created just for arithmetic and is still doing arithmetic. Your computer only adds, right? And it's basically use a base 2 number, 0 and 1. So when you subtract, it adds a sign value or a negative number. And when you do division, it's just subtraction multiple times. When you do multiplication, it adds multiple times. So at the low level, right, if you talk to people who learn how to do assembly, a lot of the assembly language, we simply use the add function, okay? So the process is that. Now, the computer does a lot of things, including AI, right? You see that. So the tasks and the processes have become tremendously a lot larger. But when you're looking at, just for communication, when you're looking at a binary address, this is what the computer sees, right? On bits, the volts reach at the peak, right? Close to 3. And then right here, it's also on, and then it drops the volts. So the electrical signal drops to 0 or close to 0 for the first octet here, and it would see that on, off, and that's what it sees as addresses. Okay, so now what we're gonna do is we're gonna do what the computer sees. We're gonna convert it as it does. Okay, so if you're given a 172, like the first octet of your IP address, and this is a decimal value, how do I know that? It is a base 10, right? IPv4 is a decimal number. It uses decimal number. So 172, let's say this is the first octet of your IP. We want to convert it into a binary so that way we can see what the computer sees. Okay. So as you know, an octet is made of 8 bits. You're gonna start from the right side. That's your least significant bit. Okay. And then going to the left side is the most significant bit. Why? Because on the right-hand side, the decimal equivalent on the first bit, if it's on, it's going to be 1. It's always going to be 1. So for those of you who knows exponent, 2 to the power of 0 is going to be 1 because it is a base 2 number. And if you use a power 0, right? So your least significant bit is the decimal equivalent. If it's on, it's going to be 1. Okay. And then as you move to the left, you are going to take that 1 and you're going to multiply it by 2. So 1 times 2 is 2. 2 times 2 is 4. 4 times 2 is 8. And remember your timetable from 3rd grade, right? 8 times 2 is 16, and so on. And you're going to stop at the 8th bit, which is going to be 128. This scale will always stay the same for the decimal equivalent for your 8 bits in an octet. Okay? Doesn't change because it's 2 to the power of n, or multiple of 2. Okay, so what we're going to do is we're going to take the 172. We know that the largest value on this scale is 128, right? There's only 8 bits. You're going to take 172, you're going to subtract it by the 128. So I take 172 minus 128, because that's the highest value I can subtract on the 8th bit to see if it's on, right? I have a remainder of 44. If you subtract it, that means that that bit is on. You put a 1 underneath, okay? And then 44 here is what's left after the subtraction. You're going to try to see if you can subtract the next value, okay? So 44 is smaller than 64. I cannot subtract. So I skip it. I put a 0. Whenever that you cannot subtract, that means that that bit is off. The signal drops, okay? So 44, I go down the line. So basically the step is take your decimal value, subtract it by the largest decimal equivalent on the bits, which is for us is 128, because 172 is higher than it. Take the remainder, go down the line and subtract it by the next bit. If you can, right, put a 1 underneath. If you cannot, put a 0. Okay. So 44 is smaller than 64. I cannot subtract. I put a 0 for the next bit, the 7th bit. And I take 44, I go down the line. Can I subtract 32? Yes, right? So 44 minus 32, I have 12 remainder. So as I subtract it, I put a 1. That bit is on. Okay. And you continue to do so until you get a 0. So once I have a 12, I go down because the 32 was the last one I subtract here. Can 12 subtract 16? No, too small. Put a 0, right? And then I go down to the next bit. Can 12 subtract 8? Yes, right? 12 is larger than 8, so 12 minus 8. As I subtract it, I put a 1. That bit is on. And I have 4 remainder. Then 4, right? I go to the next bit because last one I subtract was the 4th bit, which is equivalent to 8. So I get to go down to the 3rd bit. So 4 minus 4, yes, I can subtract it. So I put a 1 and I have 0 left. So since I subtracted here, right, and I have nothing left, the last 2 bits is off. I don't have 0 smaller than 2 and 1, so you put a 0 and a 0. So your answer for 172 is going to be, you write it down 1, right? 0, 1, 0, 1, 0, 1, 1, 0, 0. So this is subtraction method. Some people teach it with division method. For me, this is the easiest way, is to look at the table and then fill in your binary as you subtract. So when you convert decimal to binary, you simply subtract the value on that scale of multiple of 2 until you cannot anymore. And as you subtract, you put a 1. If you cannot subtract, you put a 0. Okay? Now, how can I check my answer, right? Do I know if it's correct? You can use the computer calculator. Open up your calculator on Windows. Open up your calculator app. Right? Yours might default to standard like this. you can click the ellipsis at the top, the lines, the 3 lines to access the menu, and you can choose programmer. It has all the conversion stuff, right? You don't need graphing calculator anymore. You just need your computer. You can go through and you can have, so we're gonna select programmer mode, and it's gonna default to DEC for decimal. So we're gonna select that option, type in 172. And then you click bin for binary, and you can verify that your answer is correct. Okay. And then if you want to, you can copy and paste your binary in there. So select clear, select bin, paste your answer in, and check to see if the decimal is 172, right? So we are gonna learn octal in the next week, and hexadecimal. Octal is mostly used for like the older systems, but I want to show you that's a base 8 number. So you tend to see those are the common number system that we can use for programming. So in programming, if you're doing like operator like and or, those are gate based. So at the low level, it actually has signals. So you have to understand that logic for computer science. So okay. Any question? We're gonna do one more. So now let's say that if you have a subnet mask that has 255, right? Remember what I said? I want to show you what it looks like so that when you can see like signal on and off, right? So if I have a subnet mask octet that has 255, again, right? Look at the scale, it's gonna be the same, 1, 2, 4, 8, 16, 32, 64, 128. Never change, right? Because it's 2 to the power of n, or multiple of 2, start with the 1. You're gonna ask yourself, what's the highest number I can subtract 255 from? 128, right? So as I do that, I take 255, I subtract 128, because that's the largest in that scale. And I have 127 as a remainder. And then can I take 127 and subtract the decimal equivalent on the 7th bit? Yes, I can subtract 64. So as you subtract, you gotta put a 1, don't forget. Put a 1, right? 127 minus 64, put a 1. So as I subtract, I have 63 as a remainder. And then 63, subtract 32, I have 31. So as I subtract the 6th bit, I put a 1. 31, subtract 16. As I do that, I put a 1 on the 5th bit. I have 15 as a remainder. And then I would take 15, subtract 8, and I keep going until I cannot subtract anymore. And this one, you can subtract every single one of them. And when you get to the last bit, 1 minus 1, you get a 0. Done, right? So when you have a 255 subnet mask, all the 8 bits, it receives the signal, so it receives high voltage. Okay. And then if you get a 254, the only bit that's off is going to be the last one. Right? Least significant bit, the 1, turns to 0. So when you do this, you start to see a pattern, and it gets easier with practice. Okay? So now we can check with our calculator if you're uncertain about your answer, right? Clear. I select decimal, type in 255, and my binary all once. Bin for binary. Question? So I've been teaching this for like 20 plus years, right? I found that this table technique works the best for all my students, for most, right? In my computer science class, I showed them 2 techniques, the division and the subtraction. The division you would write from bottom to top, left to right. So it's a little different, but subtraction is the easiest way. Okay, any question? Oh, you guys are doing good. To be honest with you, when I first learned this, right, I had a teacher who, like, he just like basically read it out of the book. So as he was reading it out of the book, it was like gibberish through my ear. And I was like, come again. And I had to go home and I had to find ways and read other books to kind of understand. And then one day I was like, you know what, I'll just make a table and then I draw it out because I'm a very visual learner, right? I highlight things, I draw things so that way I can remember. So I was like, oh, if you put it on the table, I see the 8 bits and on and off. Oh, okay, that makes sense. And the next week I came in, I'm like, I got it. Like, I think I got it. And the same thing with subnet. So, you know, whatever works for you, right? This worked for me, and I felt like through my experience, it worked for my students. So if you have any questions, let me know. But there are lots of YouTube videos on how to do this different ways. People have different techniques. So, okay. One more. Okay. So now we're going to do 127. So when you do a loopback address, you're going to see 127.0.0.1. Right? I intentionally pick these numbers so that way when you do a ping or when you look at a loopback today, right, you can see what that means. So you're going to convert the octet that you see here, 127 in decimal to binary. How do you do that? Okay, I'm going to take 8 down to the next page so we can see it. Okay, so to start, 127 is less than 128. We cannot subtract, put a 0, right? Too small. So we're going to go to the next bit, the 7th bit. 127 minus 64. As you subtract it, you put a 1. And you are going to have a 63 remainder. Okay? And then 63 is larger than 32, so I can subtract it. So 63 minus 32, I put a 1 for the 6th bit. And then I have a 31 remainder, and you keep going, right? 31 subtract 16. I put a 1 as I subtract it. I have 15 left. And then 15 subtract 8. And I have 7 left. So as I subtract, I put the 1. And I continue to do that until I get to the least significant bit, right? The right bit, which I ended up with nothing left, 0. So when you're looking at the 127, right, IP address, the absent bit is the 8th bit, the most significant bit, right? So everything else is fine. And again, you can use your programmer calculator to verify your answer. Any question? So some of this, right, might come up on quiz or exam, a few questions. On the final exam, you will not be allowed to use a programmer calculator, but you will have access to a scientific calculator. You can use a scratch paper if you need to. I don't mind, right? For, you know, a lot of my programming classes, when I go over this, they always like take a screenshot or picture of their scribble. They handwrite and they do this on a worksheet, right? So whatever works for you, that's fine. I don't mind if you use scratch paper to be able to solve this, but as you can see, you can practice and it gets really easy. Okay, any question about decimal to binary? So next week we're gonna do hexadecimal, so I'll elevate the difficulty a little bit. Gradually, because otherwise you were like, oh no, I don't want to learn this anymore. Okay. Now we're gonna go in reverse. If we subtract going from decimal to binary, when you go from binary to decimal, you add. Easy. Okay, so let's do 9 together. Okay, so again, your scale is always gonna be the same. 1, 2, 4, 8, 16, 32, 64, 128, right? Because it's multiple of 2. So the first step is to take your binary and place each of your binary value into the scale. So you type out 1, 1, 1, 1, 1, 0, 0, 0, because that's what you're given here, right? Just don't skip a 1 or a 0, then your values are completely different. Okay, so as you put the 1s and the 0 into the scale, the bits that have a 1, you add the decimal equivalent. You see the highlighted one? Those are the ones that I had once. Okay, I have the ones here. So I add the value that has the ones and not the value that has the 0. I don't care about those. Because if it's off, it's not significant. Okay, so I would take 128 plus 64 plus 32 plus 16 plus 8 and forget the rest. And I have 248. Easy. And then for 10, same thing. You use the same scale. Okay. You place each of the binary value onto that scale. And you would only add the decimal equivalent for the bits that have the ones. So that will be the 1, 2, and 3, the least significant bit from right, and it will reach the third bit, the rest is off. So 1, 2, 4, that gives you a 7. In an octet, 7 is the max value. We'll talk about that next time. But, right, so the last 3 bits are on. So when you get a 7, right, let's say in the host ID, that's how it looks like. And then if you have a 15, this bit is also on 8 plus 7. Right? It can be fun. But this is probably the most math that you're gonna get for now, right? Next week we're gonna do a little bit of base 16, but mostly arithmetic for networking class. And nothing crazy, right? I don't try exponent because some students are like, what's an exponent? And because not everybody has taken a certain math. So we'll just do addition, subtraction, at most multiplication, but that's it, right? Or division. So, okay, is that okay? Any question? Okay, let me move this one up. Maybe it'll fit. Okay, so do practice for 11. Same thing, right? You are going to take the binary that you give it up here, right? So it has the least significant bit on and the most significant bit on, the 1 and the 8 bit. And you would place that onto your octet table or your byte table. So 1 0 0 0 0 0 0 1. And you would only add the value of the decimal equivalents if it has a 1. So 128 plus 1, that gives you 129. And I normally put the base 10, right, to indicate that it's a base 10. You don't have to, but technically, right, this little, and you can use the button up here, the X with the little lowercase here, right? So, or, you know, we don't use the exponent one, but normally binary values is only 0 and 1. Some textbook, they would put a little 2 at the base to show it's a base 2, but you don't have to. In hexadecimal, we're probably gonna have to do that because it has letters and numbers, and sometimes it can be confusing to people. Okay. All right. So today you basically learn binary number system and how to convert decimal to binary and binary to decimal. We'll talk about hexabinary down the line. Okay, question? All right, let's go over classes then. Okay, so I described the concept in your notes, right? Putting down the steps, describing each of the steps, right? On when you go from decimal to binary and binary to decimal. So that will be a good point of reference. And you can always go back to watch the videos, and so on, right? So let's talk about class. Important to know your class. This shows up on certifications all the time. So you have to know your classes for IPv4. So class A, when we're looking at the class and the type of IP address we're working with, you simply look at your octet. If your first octet is in the range of 1 to 126, you are using a class A, right? So what do I say by an octet? So for example, if I'm looking at this address right here, right? The first octet is 126. It is in the range of 1 to 126. It is the class A. So a 10.0.0.1, 10 is within this range, right? So that is the default class A. And the default class A use network host or 255.0.0.0. Okay. And this is just the standard. This is what we follow. So when we say this, we know that there are 32 bits in an IP address. So if there is the first octet is the network ID, that will give us this many networks. So if you take 2 to the power of 8, you're going to get a number, right? And that would be the amount of networks that you would have using class A. Now, class A, the reason why we use class A is because we have the most number of hosts, 2 to the power of 24, right? And so 2 to the power of 24 is going to give you many, many, many hosts, but fewer networks, okay? So there's only 32 bits you have to give or take, right? So what you see is we can have more hosts, many computers, and then fewer networks, okay? Now class B, the 172 that you saw earlier, the first octet is in between 128 and 191. So that will be class B, okay? So that will be 65,000 hosts. So if you take 2 to the power of 16, you're going to get roughly 65,000, right? And then you're going to get about approximately 16,000 networks. So class B is kind of in the middle. So it's still pretty large. If you need to support 65,000 hosts, right, use class B. So you're going to get. Okay, and then class C is the one that you use at home, 192. Okay, so that means that you have 254 hosts. Will we ever have? I have never seen a household that have 254 systems. So I would be, that will be probably a slower network. But as you know, that your routers mostly support around 125, 27 devices. Anything beyond that is gonna be crawl. So, right? So this is why you are getting a 192, right? Your manufacturer had thought about this and said, okay, well, we're going to use 192 because that's for smaller networks. Why? Because your network ID, right? You can have fewer hosts. I think this is wrong. Yeah, this should be reverse. So 2 to the power of 8. I can't write the postscript. Okay. And then. So you can have many of the little networks, right? But your host is going to be limited to just this many, the last octet. Okay, Now, class D and class E, we don't touch. Number one, D is used for multicast group, and we'll talk about multicast shortly. So multicast is a way that we can send to a group of systems. Broadcast is to all systems, and unicast is one system. So unicast one system, multicast is a group of systems, right? And broadcast is all systems. So your communication or your network appliance, some of them do that, right? Some of them would have unicast groups, and then some of them would be broadcasting. Your wireless router broadcasts as SSID. So it's beaconing, right? It's always advertising, here I am, connect to me, I am this SSID. If you select that option on, right? So it broadcasts to all your mobile devices. Now, multicast groups, this is gonna use class D, and then your class E is only for research purposes. So we don't really touch this. So in a local area network, you can use any class, any IP address of your choice, right? Administrator by practice, right? My generation and older, they are trained to use 10 in a class A, right? Can you use 14, 18, 21? You can, right? So your network, you can create it and make sure that you schematically think about that, right? And then 192 for class C, that's just the standard that we use, but you can use like 198, you can use 200, anything in that range in C is fine, right? But the public IP address is given to companies, okay? And so when you hire or you lease a domain, a server to host your website, right? That domain is given a public IP, right? So you are, and it's to the vendor. So you subscribe that service with GoDaddy, with whoever, then they have a range of IP to use. Okay, same thing with cloud company. Now Google has multiple IP address. You if it's like 216 like this, right? That's a class C. But if you look at Google range of IP that's given to them publicly, it's 8.8.8.8, right? Or X. They hide that now. I think before you can see a lot of it online. But now you can't. Okay, let's go through and answer 12 through the next 3 questions. Given the IP address 10.0.0.101 and the subnet mask is 255.0.0.0, which class of IPv4 address does the given IP belong to? So I highlighted the octet that you need to look at. You look at the first octet, right? And you verify that with the subnet mask. This is a default class A, right? Look at the table. Default class A. And then at your home computer, right? Let's say that my home computer have 190, it has 192.168.0.23. You look at the first octet again, right? And you look at the subnet mask. That's your network ID right there, right? That's the default class C. So sometime, I'm going to tell you this now because when you do the Linux part of the lab, you're going to be like, oh, that's a CIDR. So sometime the 255.255.255.0 is also indicated as a CIDR 24 because the first 24 bits is on. You see? Right? Remember? 8, right? 8 and 8. We did the calculation for the binary conversion. So 8 bits, 8 bits, and 8 bits. You add them together, that gives you a CIDR 24. So it indicates as a /24, whereas the class A, default class A, when it's like this, it would only indicate like, so the 255, sometime it would be your, that will be /8 like that. So some system, it doesn't have it written out with 255.255.255.0. They would have it as /24. And you see this in a lot of network appliances. So when you configure it, right? You don't have to type out the entire subnet mask, you just type the slash and then the CIDR value, which is the number of bits that's on for that subnet mask. And then if you're looking at the school computer, let's say that it's 10.111.90.11 again, right? We are going to refer to the first octet, but wait a minute. If you look at the subnet mask, it is a subnet mask. Yes. No, so 224, if you convert that back, pick your programmer calculator, right? Go and let's clear this, put in decimal 224, right? How many bits is that? 3. You see? 3 bits here. So that means that I have 8 plus 8 plus 3, which gives me 19. That's a CIDR 19. Because there's 8 bits here plus 8 bits here. And if you convert 224 to binary, there's 3 bits. So that's 8 plus 8 plus 3 is 19. You see how it borrowed the first 3 bits? That's subnetting, is to borrow, to lean into. It's a class A address, but it borrowed into a class C. We'll touch on that later, but yeah. So now you see the value in understanding binary, right? You can put in the right CIDR. Good question. Okay, now, so how do I find my IP address again, right? I know some of you are writing down the answer, but real quick to confirm, right? If I'm connected to the network right now, and if I do IP config, right? If you look right here, see? They subnetted. That's my IP right now, right? And my subnet mask. So this is the same thing, right? CIDR 19. You take 224, convert that to binary, you get 3 bits, 8 bits, 8 bits, so 8 plus 8 plus 3, 19. Okay. For 14, given the IP address 172.10.0.80 with the subnet mask 255.255.0.0, which class does the IP address belong to? That's the default class B. You look at the first octet, you look at the subnet mask, right? Verify that it is a class B. Use the table. And then why is class D or E IP address not used, right? D is reserved for multicast groups with an S, and E is for research. We don't touch those. Reserved with the D. Have some grammatical error there. Question? Okay, so before we go to a little bit of a different direction when we're talking about addresses, right? Let's flip back to the notes. So after your classes, right? There's a section on loopback address. This is how it can see itself, right? Through the loopback address, you see its own connection. So you always gonna use the 127.0.0.1. Sometimes some system you can ping it by host name, right? But if you ping it, you use the 127.0.0.1, right? It's only gonna come right back to that system. That's how we can verify that it is connected. It's pinging back. It's gonna loop back to that system. They say that calls home, right? Okay, So we're gonna look at this section. When you are setting up IP address for actual systems, server, PC, mobile devices, copier, printer, you cannot use the 0 for host ID or 255 for host ID. No, right? 0 for host ID indicates that this is a network ID. We don't use 0 to give out to system. And we don't use 255 at the end. So when you look at the last octet, it cannot be 0 or 255 for the unique system, for the client systems, for the servers, right? But in the routers, sometimes you have to program that in to say that this is the network that you want. Okay. But when you started to use IP for individual system with the host ID, you have to start with the 1 through the valid value, right? So if it's 224, then you only have 223 to work with. So in the case of 255, I have 254 systems to give out IP to. Okay, so the .x here cannot be 0 or 255. So let's answer the next question. When you go down that list, so A, 192.168.0.0, look at the last octet. No, cannot use, right? Cannot be assigned because it's a network address. It cannot be used for the individual unique system because if you see a .0, right, that's a network address. B, again, we look at the last octet, 255. It cannot be assigned because it's a broadcast address. So for a broadcast address, 255. Network address 0. We don't use those for regular connecting system. 127.0.0.1, we just talked about this. We cannot give this to a system. It already uses this to see itself. So no, cannot be assigned. It's a loopback address. And then D, right? D, you look at the last octet. Yes, I can give this to the system because a .1 is a unique value. It's not a broadcast or a network address. So I can, usually a .1, like I mentioned to you, is a gateway or a router, right? So I can configure this. I can use that IP address on a router. And subsequently for E, same thing, right? You look at the last octet where I highlighted in teal or blue, whatever. So the 103 is not a 0 and it's not a 255, right? And it doesn't represent a loopback. So it can be given to a system. And then for F, if you look at the address, well, the last octet is okay, but the first octet is not, right? This belongs to class D. 224 belongs to class D. So you cannot use that address. And similarly for G, same thing. 5, the host ID is okay. But your network ID here, the first octet, the 246, it belongs to the range of class E. And class E is used for research. We don't use address in that range. And then for H, you look at 182.3.116.7. You check the first octet. Yes, it is in a class that we can use. And the 7, that is unique. It's not a 0 or 255. So you can use it for a system. Any question? We only have 24 today, so I'll try to get to 6:30 take attendance and then we'll do a break, right? And then I'll let you get started on the lab after that, but, okay. So now, let's talk about the difference between private and public IP. As you know that everything in the internet that is used, like for example, cloud servers, domains, web servers that you can reach like google.com, those use public registered addresses, right? There are an organization that manages the world DNS and the IP addresses for all continents. And what you see is you see that those are given to the internet service provider or the vendor like Microsoft. They have cloud systems, so they own a huge range of IP address. Microsoft owns actually one of the few companies that have the most. Coca-Cola used to have a lot because long ago in the 90s, they realized that IP address is going to be hot commodity, and so they acquired IP addresses and eventually they sold some of that, right? But you see that a lot of the internet service provider, the cloud, the mobile service provider have public IP addresses that's registered, that's given. So the private IP addresses is non-routable, right? It's used inside your network. It's kind of like, you know how at home inside your house, they call you a nickname, but nobody knows you by that name outside, right? So everything is by the legal name. So the public IP is like the legal name for that system, the legal ID for that system to the world, right? But inside our network, our private IP, you can design however based on the number of systems that you're connecting, right? And you know whether you want the subnet or not. So private IP addresses is used within your LAN. It's non-routable. Now you can have it routable, right? We talked about adding the switch and all of that, but still within the network, it routes, you know, it treats different segment as different town, right? Different city. So they're used for LAN. And network address translation is your NAT. So when you boot your virtual machine today, if you click on the network tab, right, on the setting before you boot, you would see NAT. Network, actually, yeah, it's the same thing for your Kali Linux. Network address translation server, it's basically allowing that system to take your private IP address and convert it, right, and bundle that through into the, when it passes through the router, it's going to use the public IP address. It translates it to a given public IP address. And so that means that the virtual machine uses the NAT on your host system, right, to connect to the RCCD network to be able to give you internet on your virtual machine. Okay. So public IP can be used for wide area network. That means that you can connect to the cloud or the internet using that public address. Now, from a security perspective, right? If they're coming into your network, you're gonna see this. You're gonna see the public IP address. But if they're already inside your network and they're and they are looking at things, right? So some of my students are like, well, you can't spoof an IP address. You sure can, right? You can use tools to do that. You can take on a system identity, just like how people steal people's identity, right? Take someone's social security number and apply for credit, for example, right? So when they're coming in, let's say that how do they know that it's a public IP from China or Russia or Africa or Vietnam, right? How do they know? Well, because every region service provider has a list of registered IP address publicly, right? And so that way your firewall is gonna say, hey, it's blocking this traffic from, you know, unknown IP from China, right? But what if that attacker is using somebody else's IP address? Well, the matter is your appliance is blocking it, right? Anything that's not known to your network, kick it out, right? That's the goal. But when they're inside your network, they're gonna take on your private IP address, and if they already got inside, right, you have to kind of follow, right? They have to spoof the MAC and the IP to get through the switches and so on. Okay. All right. So I think we talked a little bit about this when we touched on the IP class. Broadcast and how that is different than multicast. Broadcast is the process of sending data to every system, all the system on the network. So everybody receives that same information. Multicast is a process of sending the data to a selected group of systems, not everyone, just a selected few or that group. So how do I know if it's a broadcast IP? Look at the last octet, and if it's a 255, we just talked about this, don't use 255 because it's for broadcast. If it's N with a 255, it's a broadcast IP. Okay? So A 10.0.0.255, that's a broadcast IP, right? B 192.168.0.1, it doesn't have a 255 at the end. It's not a broadcast IP, right? We don't use that as a broadcast IP. We can assign that to a system, but not use it as a broadcast. C, again, look at the last octet. It's 255, so that's a broadcast IP. Same thing with D, right? Now E, if it is a default class address, then you can use this to assign to a system, and it is not a broadcast IP. But if it's subnetted, and if the subnet mask, the last octet is 254, it's a broadcast IP. So in general, this one is not a broadcast IP, but there's exception. Any question? Yeah.
So what is the 55? It's a lot.
Yeah, if you use 255 in your subnet mask. So that really represents the all the bits are on. So your switches and routers, not too smart, because it has very little RAM, right? To store the relevant table of the system. It's just gonna compare signal. If all the signals on the 8 bits, oh, that broadcast, let's send it to everyone. Forward it to all ports, right? Where if it's not on for all the 8 bits, then it doesn't forward to all ports. That's it. Question? Okay, I'll move 18 down since if we're recording that. Okay, so let's talk about ports. So when we talked about protocol, we looked at port number, right? And I mentioned that's really important. So in general, port physically or logically is a way that we can allow, right? Enable, run a certain type of service, like web on port 80. But physically, it's a port is a way that we can connect the cable to or the media to that physical connection to get electrical signal. So when you're using dynamic port, basically it is a way that we can use a range of port, right? To be able to use whichever. So for example, we would say port 65,000 to port 6550, we're gonna be able to be flexible and pick whichever one. I can use 65,001 or 65,020, right? So in that range, I can dynamically pick a port, right, that is available for that application. And they do this for convenience, fast response, performance, etc., right? Also from a security side, you're not tied to a specific port where someone can find that and attack you and take down your service. So a lot of the times the vulnerability sometimes is tied to that connection. It's kind of like I know that you are gonna drive through that gate, right, or go through that door, I'll just block the door so you can't go, right? So the way that they attack you is either finding the port, this, making sure that your port is flooded or whatever, right? Or making sure it's not available. That's how they can do denial of service on you, right? So in this case, if you're using a dynamic port, basically you have a range of windows and door, right? I can go through window 1 to go out and come back in window 10, right? So it allows you the flexibility to run your application temporarily on these ports for certain tasks, right? But doesn't have to be permanent. Now the common ports, some of the things we're gonna see that on Wireshark today, right? Like 53 is for DNS, and it's exactly 53 for DNS server. No more, no less, right? But when you are a system that you're connecting to the DNS, you might be using a dynamic port because there are many clients, right? In the school, you can have like 60,000 computers, and it might be using a lot of different ports in that range, right? So it gives you the flexibility for your service and also capitalize on the availability of the ports. Okay, so how can I find this information? After you get through the private and the public IP address and NAT, and I touched on a PIPA earlier, APIPA. This is an address that you get when you install OS, right? First off the bat, when your system has not been connected to any network. When you see a 169 in the front like this, it is not a usable IP address. That means that you have not been connected to any LAN, right? Or you don't have a socket for network connection. So what you see is you're gonna see something like this, and this should be giving it away in 255. You already know it's not usable. So when you look at it, you might think it's an IP address. I have a lot of students that troubleshoot and they get stuck right here. They think it's an IP address, but it's not a legitimate IP address, right? So this is just like something that they place there before you get. So once you get connected to a network, like you join a wireless network, the wireless router will give you its IP address in the scope of the DHCP. Then you would get like the 192. That's a legitimate IP address. This is not. Okay. Okay. Here it talks about a virtual IP that you can use that's not on a physical network. You see some of this with virtual machine. And then the ports are here. So register ports are ports that are assigned to the protocol. Like we talked about the protocol, like HTTP port 80, that's a registered port. It's also fall into the common port or the well-known ports, right? So the range for the common port is like about 1,000. They say 2,000 now, but it's approximately 1,000. And then subsequently you have the register ports following that, and then the dynamic port. So if you look at the packets today, right, I challenge you to determine whether it is a well-known port, right, a register port, or a dynamic port to really see the application in this, right? So when you get to the DNS section, likely that you're going to see this and the well-known ports, okay? So even when we generate port 80, you already see that with the well-known port. So I put a link for your common port list here, and it talks about the socket here. I know it's 30 already, but we got to go through a few more. Okay, 21. Describe a socket. It needs to be made of 3 components. Okay, a socket is not a port. A socket is an endpoint of communication that's made of 3 pieces: IP address, a port number for the service or the application, and a protocol. It's either TCP or UDP. That is what made up of a socket. So when you see a configuration and it requires the socket, you need to make sure that it have the relevant IP address, the port number, and the protocol, which is tied to the service that's used. Okay, we're gonna have a chapter specifically on switch and a chapter specifically on router, right? But we're gonna preview some of the server stuff. Next week, you are gonna configure DHCP. So you're gonna create a scope of IP to give out to system, right? So I wanna make sure you know how to set up that kind of server. But this week, we're gonna look at the traffic in our network and look at the packet information. 22. Why is BootTP important in a network? So when you configure a router, especially a router that would handle DHCP requests. So for example, if I remotely work from home, I need to connect to my computer at my desk at work, right? I have to authenticate and connect through the firewall to be able to, so it routes in my traffic. And then eventually I'm going to be able to obtain an IP address from my company's server, right? To be able to connect like I connect on my desktop at work. So your routers needs BootTP to allow the DHCP request to pass through, right, the router or another segment. And so if you set up your router to be able to handle your DHCP requests across the network or coming in from external network, you need to make sure that this protocol is available or configured. Okay, so here, we're gonna do a little bit of this in Linux today, and then we will do this in Windows down the line. Okay. Your Windows 10 actually had static IP already when I copied it. Okay, dynamic host control protocol, which goes over the next one. This is a service that your server would hold as a role to be able to give out IP addresses to the systems that are connected. Your wireless router do this at home, right? We are going to set that up using Windows OS, Server OS next week on the virtual machine, so you can see how that works. But one of the server that we would see with your .org, .net, .com is your DNS. That simply takes a public IP and it ties it to the FQDN. This stands for fully qualified domain names. Your google.com, your youtube.com, your nbc.edu, right? Some are top level domain like the .com, .org, and then you also have the low level domain, not top tier, is like the .io, .it, and this is what you see. So all your web server is connected to your DNS, which is how it's able to correlate, right, the URL to your public IP address, okay? And there's only a few people in the world that host the world DNS list, right? So which IP address to which DNS, okay? You guys can do whois to kind of find out, right? Like who is google.com. And if they allow you to see it, they will give you the public IP that they have and the FQDN. Okay, so your DNS. And DNS use the common port 53. Okay. Okay. So we talked about the default gateway already. That is usually the router address, which is it has the unique host ID as .1. And then your servers right here, right? DHCP, DNS. We talked about a PIPA address. Boot protocol, BootTP is right here. Okay, let's talk quickly about IP reservations. Let's say that you have a server that gives out IP address, right? To thousands of systems. But then you decided that in that group of IP address, you want to keep some for other servers, for other appliances. Like you might want to add a network intrusion detection system. And again, any dedicated system, right? That means that it's shared or it's used by a lot of systems. We don't change IP address. We keep the IP address static and pre-configured, right? So, because if you use dynamic address, right, sometime down the line, the 500 system cannot be connected, you're in trouble, okay? So static IP address, not dynamic IP address, okay? So what you can do is you can reserve IP addresses for a certain system, right? Like I want to reserve the first 100, the .1 to the .100 for my servers, my switches, my security appliance, my copier, my printer, right, etc. So you can create a reservation list on the DHCP so that way it doesn't give out those IP addresses from the pool. Okay, and then lastly, we're going to talk about WINS. So when we install DNS, you're going to see this as the last step in the DNS. Before DNS and before using IP address, we used to identify system by name. And so Windows Internet Naming Service is known as WINS or WINS, and it provides name resolution through NetBIOS. In the back, you would see that the domain controller and backup domain controller still using this in Microsoft environment. And when you install it, it's default as enable, right? If you just click next, for the DNS, it is a way that we can still navigate through the network by looking at the host name and where that host is located. But technically, we should use everything with IP. But sometimes you would see domain and subdomain in hierarchy level, and we would do that with the separation in the fully qualified domain name under the. So if you take Microsoft administration class or system administration class, they might address that, but we will see this when we install DNS in the future. Okay, so it is a way that we would resolve system by names. Any question? Sorry, I'm like 8 minutes over, but that was the plan. Okay, let me stop share so I can